Day 681 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1622, fancy sequence. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Write an API that generates fancy sequencing using the append, add all, and multi all operations. Implement the fancy class. Fancy initializes the object with an empty sequence. The append function appends an integer val to the end of the sequence. The add all function increments all existing values in the sequence by an integer, and the multi all function multiplies all existing values in the sequence by an integer m. The getIndex function gets the current value at index IDX of the sequence modulo 10 to the ninth power plus 7 if the index is greater or equal than the length of the sequence, return -1. All right, y'all, so that may seem a little bit confusing at first, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So before we get into it, I want y'all to understand that each one of these represents one of these functions over here. So let's get into the example and see what they want us to do. So in example one, or matter of fact, before we get into the examples, let me copy and paste this over here so y'all can see what is going on. Boom. Then this will be our sequence array, and this will be our output array. Boom. So each one of these strings, and this we have this array of strings right here, and we have this array, 2D array of integers right here. Each string represents a function, right? A function call. So first we're going to initialize the fancy class. Then we're going to call the append function. Then we're going to call the add all function. Then we're going to call the append function. Then we're going to call the multi-all function, and so on and so on. Now each one of these function calls corresponds to or each one of these function call strings appends to one of these integers, or excuse me, corresponds to one of these integers. So this append at index 1 corresponds to this 2 at index 1. This add all at index 2 corresponds to this 3 at index 2. This append at index 3 corresponds to this 7 at index 3, and so on and so on. So when this says appends an integer val to the end of a sequence, we're going to call this append at index 1, and this 2 is going to be a val. When it says increment all existing values by an integer, we're going to call this add, or for this function, this add all function. So this add all, we're going to the increment is, we're going to increment it by this value right here, 3. So when we say call add all, the value that we'll be adding to all of the elements in the sequence will be this 3. When we call append, it'll be this 7. So once again, each one of these corresponds to the corresponding index. Each index up here corresponds to the corresponding index down here. So now that we understand that, let's look at this explanation so we can see what's going on. Now, first thing we do is we're just going to initialize the fancy class. Boom. So our output will be null. We don't need to return anything for that, and that's why it's a blank array right here, because there's no integer to call. We're just initializing the class. So this is the sequence. This will be the output. We could just put null right here, and then we could delete this because we called it already. Boom. So now we're going to call append, the append function, with the value of 2. So let's see what the append function does. It says we're going to append an integer val to the end of the sequence, right? So explanation says fancy.append 2. Fancy, now the sequence is 2. So this is the sequence. We're going to put a 2. We're going to append 2 to the sequence. Boom. So that's what this append does. We just append 2 to the sequence. We called it already. We could get rid of it, and we could put a null down here because we didn't return anything. Boom. Now we're going to call add all 3. So let's see what add all does. The add all increments all existing values in the sequence by an integer. So we're going to add 3 to all of the values in the sequence. Right now there's only one value in the sequence, which is 2. So let's see. It says fancy that add all 3. So the fancy sequence, so 2 plus 3 equals 5. So we add 3 to all values in the sequence. Now that 2 becomes 5. And we can put a null right here. Boom. So let's get rid of this. Let's get rid of this. Boom. Now we're going to append. So we're going to append this 7. So let's see what append does. It says append appends an integer value to the end of a sequence. So we're going to append this 7 to the end of the sequence. Boom. Just like that. So let's see. It says fancy.append 7 fancy sequence now is 5 7. That's what it looks like. Boom. And we could put a null right here because we didn't return anything. Boom. So we appended the 7. So let's get rid of this. And let's get rid of this. Now we're going to call mult all on 2. So that means, see what mult all does. Mult all multiplies all existing values in the integer in the sequence by an integer m. So we're going to multiply all the values by 2. Boom. So let's see. It says fancy.mult all 2 fancy sequence 5 times 2 and 7 times 2. The sequence becomes 10 and 14. So we're going to multiply this 5 by 2. That becomes 10. And we're going to multiply this 7 by 2. That becomes 14. Boom. And once again, we could put a null right here because we didn't return anything. Boom. Now we're going to call getIndex. It says getIndex gets the current index ID x of the sequence. So we're just going to get the index, right? So getIndex 0. So we want getIndex 0. Boom. Index 0 is a 10. So once we get the index, we're going to return the 10 right here. Boom. So let's see. It says fancy.getIndex 0, return 10. Boom. So we add 10 to this output. Boom. Call that. Let's get rid of this because we called it. Now we're going to call add all 3. That means we're going to add 3 to every value in here in the sequence. So once again, fancy add all 3. 10 plus 3, 14 plus 3, 13 and 7. So we'll add 3 here. 13. We'll add 3 here. That becomes 17. Boom. So we call that. Let's get rid of this. Boom. Now it says append 10. So let's see. Fancy.append 10. Now the sequence is 13, 17, and 10. So let's add 10 over there. Then we can get rid of this. We can get rid of this. Now we're going to call mult all. Boom. So mult all 2. So that means we're going to multiply everything in here by 2. It says fancy.mult all 2. Fancy sequence 13 times 2, 17 times 2, 10 times 2 is 26, 34, and 20. Boom. So we actually, and we forgot to put the null right here. Sorry, y'all. So this should be null. We actually forgot a few nulls. This should be null. We're at mult all. We're at this mult all. So it should be. We forgot 2 appends. Sorry, y'all. I mean 2 nulls. Sorry, y'all. Boom. Now we're mult all 2. That will be. We already. Or did we do that? No. So we need to multiply this by 2. That's going to be 26. We need to multiply this by 2. That's going to be 34. And we need to multiply this by 2. That's going to be 20. Boom. Now we did that. Now we can get rid of this. And we also need to put the null here. Boom. Now we call getIndex. So getIndex at index 0. That's going to be index 0, 26. Let's check that. Yep, 26. Put the 26 here. Boom. Let's get rid of this. Boom. Boom. Then we're going to call getIndex at index 1. Index 1 is 34. Let's check. Yep, 34. So we put 34 here. Boom. We get rid of this. We get rid of this. Then we're going to call getIndex at 2. Index 2 is 20. So we're going to put it here. We'll say here. Boom, boom. And that's it. So we get rid of this. This output should look, let's see. Make sure they line up. They should. Boom, y'all, they line up good. So that's what I'm talking about, y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, the first thing we need to do is we need to create a constant for this to handle this modulo 10 to the ninth power plus 7. So we'll just come right here. We'll say private let mod, we'll say colon and 64, and we'll set that equal to 1 underscore 000 underscore 000 underscore 007. Boom. So this right here represents this right here. Boom. Then we'll come underneath that, and we need an array storing tuples for each appended value. So we're going to get the original value, the multiplication factor at insertion time, and the additional value at insertion time, and this will allow us to reconstruct the final value later when get index is called. So we'll say private var values equals an array of tuples. So we're going to say open square bracket, open up the parentheses, int 64, comma int 64, comma int 64, and we'll put the parentheses like this. Boom. Now we need a global multiplication factor applied to all elements. So we're going to say private var mul colon. So we're going to cast it as int64, and we'll set that equal to 1. Then we need a global addition value applied to all elements. So say private var add colon int 64, and we'll set that equal to 0 to start. Boom. Now we can leave the initializer alone, and let's get into this append function. So this is going to store the value along with the current multiplication and addition state at the time it was inserted. So we'll say values dot append, open up the parentheses, open up some more parentheses. We're going to say int 64, open up some more parentheses, pass in val, come outside of that, say comma mul, come outside of that, say comma add. Boom. That's it for the append function. Now, for the add all function, we're going to add a value to all elements in the sequence. Instead of updating every element individually, we update the global addition offset. So we're going to say add equals, open up the parentheses, add, comma, plus int 64, open up the parentheses, inc, come outside of that, and we're going to say mod. Boom. Then we need to handle this mult all function. So for the mult all function, first we need to multiply all elements in the sequence by m. Or first we need to create, we're going to create a constant. We're going to say let mm equal int 64, open up the parentheses, pass in m. Then we're going to update the global multiplication factor by coming underneath this. We're going to say mul equals, open up the parentheses, mul times mm, come outside of that, and we'll say mod. Boom. Then the addition offset must also be multiplied to maintain correct transformation order. So we'll come underneath this, and we're going to say add equals, open up the parentheses, add times mm, come outside of that, and we'll say mod. Boom. Now, before we get into this get index function, we need to create a helper function. So this is going to help with fast modular exponentiation. Sorry, y'all. And it's going to compute a squared or a to the b power mod efficiently. So we're going to say private func mod pow, open up the parentheses, underscore a colon int 64, sorry y'all, int 64, comma, underscore b colon int 64, and then we're going to return int 64, open up the brackets. Boom. Then we're going to declare a variable called base, set that equal to a. We're going to declare a variable called exp, set that equal to b, and we're going to declare a variable called res colon int64. We're going to set that equal to 1. Boom. Now we're going to loop while the exponent is greater than 0. So we're going to say while exp is greater than 0, we're going to open up the brackets, and if the current exponent bit is 1, we're going to multiply the result by the current base. So we're going to say if exp and 1 equals 1, we're going to open up the brackets, and we're going to say res equals res equals, open up the parentheses, res times base. Come outside of that, we're going to say mod. Boom. Then we're going to square the base for the next bit. So we'll come underneath this, and we're going to say base equals, open up the parentheses, base times base. Boom. Come outside of that, and we'll say mod. Then we're going to shift the exponent right, or meaning divide by 2, by saying exp right shift equals 1, and we can come underneath that, and we can say or outside, sorry. Hold on, y'all. One moment, because oh yeah, we'll come outside of this, and we can say return res. Boom. But we're not done yet, because we still need to handle this get index function. So for that, if the index does not exist, we need to handle that, because we need to return -1. So we could just say guard idx is less than values dot count, else open up the brackets, we can return -1. Boom. Then we need to retrieve the stored value and transformation state at the time this value was inserted. So we'll come underneath this, we'll say let, open up the parentheses, val, comma, mul, at insert, comma, add, at insert. Boom. Then we'll set that equal to value square bracket idx. Boom. Then we're going to compute the modular inverse of the multiplication factor at insertion time. So we'll come underneath this, and we'll say let inv equal mod pal, open up the parentheses, mul at insert, comma, mod -2. Boom. Then we're going to determine the effective multiplication factor needed to bring the stored value to the current state. So we'll come underneath this, and we'll say let factor equal, open up the parentheses, mul times inv, come outside of that, and we'll say mod. Boom. Then we're going to apply the necessary transformations to compute the correct current value. So we'll come underneath this, and we'll say let result equal, open up the parentheses, open up some more parentheses, we're going to say val times factor, come outside those parentheses, mod plus, open up the parentheses, add, minus, open up some more parentheses, add, at, insert, times factor, come outside of that, we're going to say mod plus mod, come outside of both of these, and we're going to say mod. Boom. Then we just need to return the computed value as an integer by coming down here, and we can say return and open up the parentheses and pass in result, y'all. Boom. That should be all she wrote. Let's give it a run. Okay, let's see. We got ourselves an error. Hold on, y'all. This should be, sorry about this. Hold on. We need to move this comma. That should be all she wrote. Let's see if that's what was messing it up. Oh, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 61 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the this is the middle part. And this is this is the bottom of the middle part. And this is the bottom right here, y'all. So yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.